Good morning. This is your stat sensei, Mr. Spensei, and this is an assignment on the normal curve. And we're going to be figuring probabilities and we'll be using the normal CDF. So X is normally distributed with a mean of 25 and a standard deviation of 3. So I'm going to go ahead and write that out. Mean 25, standard deviation of 3. And by the way, all of our problems are going on this problem one part there's a part A, B, and C, and all of them will be using those values. So what's the probability that X is less than 30? Well, that's interesting because our mean here is at 25 and we have an X value of 30. And it says less than, so we're shading this way. And don't forget this goes to negative infinity. And that's not a very good 30, at least not for this, but that's what that is. So we want to go to the NormCDF on the calculator, NormCDF. Our lower bound is negative infinity. Our upper bound we shaded to 30. We have a mean of 25 and a standard deviation of 3. Once again, this is our LUMO. L, U, mean, standard deviation. So second vars, normal CDF, lower bound negative 9 raised to the 99th, upper bound 30, mean 25, standard deviation 3. And we end up with 0.9522. Let's go ahead and box that answer. The next one, we want the probability that X is greater than 20. So our mean is at 25, and we have an X here at 20, and they said, hey, greater than, so we're shading up, and don't forget, we're shading up to positive infinity, and 25 is the halfway mark, or 50%. So we're gonna should have a value that's greater than 25% when we're done. So we're gonna do a norm CDF. Lower bound of our shading was 20. The upper bound was positive infinity. Mean of 25. Standard deviation of 3. So lower, upper, mean, standard deviation. Second vars, normal CDF. Lower bound, lower part of our shading was 20. The upper bound was 9 raised to the 99th. Mean of 25, standard deviation of 3. And we end up getting 0.9522. Why are these two the same answers? Did we make a mistake? Well, this is 5 values above and shading down. This is 5 values below and shading up. So because it's symmetric and we're the same distance from the mean, we should get the same value, and we did. All right, the next one, 25 to 28. Well, here's our mean at 25. Here's our X value at 28. And we're actually looking for that value in between. So this will be a norm CDF. Lower bound of 25, upper bound of 28, mean of 25, and a standard deviation of 3. Now, it freaks people out sometimes if there's two 25s. And the reason there is our lower bound happened to be exactly the same thing as our mean, and that's what we showed when we shaded. So here we go. Second vars, normal CDF, lower bound 25, upper bound 28, mean of 25, standard deviation of 3. and we end up getting 0.34134. So 0.3413. All right. Number two, the daily high temperature in a specific city during it is normally distributed with a mean of 68. So mu equals 68 and a standard deviation of 4. What is the probability the temperature exceeds 72 degrees? So we're looking for the probability that X is greater than 72. Well, if I draw my graph, mean of 68, well, we know 72 is up here. And we're looking for this area. Please don't forget, this goes to positive infinity. So we're going to have a NormCDF. Lower part of our shading was 72. We went up to positive infinity. We have a mean of 68 and a standard deviation of 4. So this is going to be lower, upper, mean, standard deviation. Second vars, normal, CDF, lower bound 72, upper bound 9 raised to the 99th, mean of 68, standard deviation of 4, and we get 0.1586. All right, number 3. The time spent by customers at a coffee shop is normally distributed with a mean of 15 and a standard deviation of 5. What is the probability that a randomly selected customer spends between 15 and 25? So we want the probability that 15 is less than X is less than 25. So let's draw a picture of it. So my picture is going to look like this. Here's my mean, oops, at 25, or I mean at 15, excuse me. Well, I'm going to change colors. I'm going to make that a 15 just because I messed up. And my upper bound happens to be my X value, happens to be at 25. And we're looking for this range right there. So that's going to be a norm CDF. Lower part of my shading is 15. The upper part of my shading is 25. My mean is 15, and I have a standard deviation of 5. So this is my LUMO. And when I go to the calculator, second vars, normal, CDF, lower bound 15, upper bound 25, mean of 15, standard deviation of 5. We end up with about 47% is in that value. All right. So 0.4772. All right. Number 4. The heights of adult women in a population are normally distributed with a mean of 165. Oops. So I'll write that off to the side. Mean is 165 and a standard deviation of 6. What's the probability that a randomly selected woman is between 160 and 170? So we want the probability that 160 is less than X is less than 170. So we're going to draw a picture. We're centered at 165. And we're going from 160 to 1, and this is my mean, X, or this is my lower, this is my upper, this happens to be 160, and this happens to be 170, and we're looking for the area in between here. So it's going to be a NormCDF. Lower is 160, upper is 170, mean of 165, standard deviation of 6. That's my LUMO. So second vars, normal CDF, lower bound 160, upper bound 170, mean 165, standard deviation 6, and we get about 60%. So 0.5953. All right, the next one. What's the probability that a randomly selected woman is between 155 and 175? All right. Well, first off, our mean is 165, our standard deviation is 6, so that hasn't changed. So let's draw a picture. Oh, so we want the probability that we are between 155 and 175. So the probability that 155 is less than X is less than 175. My picture is going to look like this. 165 here. That's my mean. I have a upper of 175 and a lower of 155. And I'm looking for this area right here. So this needs to be a NormCDF. And that's my lower of 155 to 175, mean of 165, standard deviation of 6. This is my LUMO. Second vars, normal CDF, 155, 175, and we have 165 and 6 for our standard deviation, and mean and standard deviation, and we end up with about 90%. So 0.9044. All right, moving on. The monthly electricity usage in a household is normally distributed with a mean of 500. So they're telling us the mean is 500 and a standard deviation of 50. What is the probability they use less than 400? So we want the probability that 400 is less than X. All right. So drawing out my normal curve. My mean is at 500. We're here at 400. Please don't forget this goes to negative infinity. And so we're looking for this area right here. Well, in this case, negative infinity is my lower and 400 is my upper. So we're going to go norm CDF, negative infinity, that's my lower. Upper was 400, mean of 500, standard deviation of 50. So there's my LUMO. So with that said, second vars, norm CDF, negative infinity. Oops. Upper is 400. My mean was 500, and my standard deviation was 50. And we get 0.0227. All right, part B. What's the probability a household uses between 450 and 500? Well, please note we're still using the same values. And I also noticed that, hey, that's 50. That should be about 68% when we do this. It looks like this is going to be almost exactly 68. So here we go. Probability that 450 is less than X, which is less than 500. That's what we're looking for. Our picture is going to look something like this. Mean was 500. Oh, I thought that was a 550. So no, this is going to be half of 68%. This is going to be closer to 34%. So mean, when we have a lower bound of 450, there's my lower, and we're shading all the way up to 500. So we're looking for this area right here. So this will be a norm CDF. Lower part of my shading is at 450. The upper part of my shading is at 500. We have a mean of 500. We got that up above. And we have a standard deviation of 50. So here's my LUMO. Second vars, norm CDF. My lower part of my shading was 450. The upper part of my shading was 500. And we end up with 34%, which makes sense. It should be about half of 68. So 0.3413. All right, number 6. The monthly rent for apartments in the city follows a normal distribution with a mean of 1,500 and a standard deviation of 200. Find the probability a randomly selected apartment has a rent less than 1,300. So we want the probability that 1,300 is less than X. So our picture is going to look something like this. We have a mean of 1,500. We have 1,300 here. And this is going to negative infinity. So I have a norm CDF. Negative infinity. 1,300. Mean of 1,500. Standard deviation of 200. So there's our LUMO. Lower, upper, mean, standard deviation. Let's go ahead and plug this into the calculator. Second vars, normal, Second vars, normal CDF. Lower bound, negative infinity, which we do the 999. Upper bound, we stopped at 1,300. Mean of 1,500. Standard deviation of 200. And we get 0.1586. All right. Has a rent between 1,400 and 1,600. So we're still working with the same 1,500 and 200. So we want the probability that 1,400 is less than X is less than 1,600. So I have a mean 1,500, 1,400, 1,600. Ran out of room. So sorry about the sloppy writing. Norm CDF, lower bound 1,400, upper bound 1,600. That's my lower, that's my upper. Mean of 1,500, and we have a standard deviation of 200. Again, this is our LUMO, L, lower, upper, mean, standard deviation. I have the labels. Second vars, normal CDF, lower bound 1400, upper bound 1600, mean of 1500, standard deviation 200, and we at 0.3829. The weights of newborn babies in a hospital are normally distributed with a mean of 7 pounds and a standard deviation of 1 pound. Mean is 7, standard deviation is 1. What's the probability that it weighs more than 8 pounds? So we're looking for the probability that X is greater than 8. So our graph is going to look something like this. We're going to be centered at a mean of 7. And we're going to start at 8, and we're going to shade up to positive infinity. So we're looking for this area right here. So norm CDF, lower bound 8. That's the lowest part of our shading. Highest bound up on positive infinity. Mean of 7, standard deviation of 1. So this is my LUMO. Second vars, normal CDF, 8, 9 raised to the 99th. Mean of 7, standard deviation of 1. And about 16%, 0.1586. Going to be really cramped for room on this one. Probability is between 6 and 7.5. So the probability that 6 is less than X is less than 7.5. Our picture is going to look something like this. We're going to be centered at 7. This is going to be at 6. This is going to be 7.5. And we're looking for the area in between. This is my lower. This is my upper. So norm CDF, lower is 6, upper is 7.5, mean is 7, standard deviation of 1. That's our LUMO. Second vars, normal CDF, lower bound 6, upper bound 7.5, mean of 7, standard deviation of 1. And we get 0.5328. So about 53%. And what's the probability that it weighs less than 6 pounds? Probability that X is less than 6. So we're shading to negative infinity. All right. So it's the norm CDF. lower bound negative infinity, upper bound is 6, mean is 7, standard deviation still is that 1 that we had earlier. So lower, upper, mean, standard deviation, or LUMO. Second vars, normal CDF, lower bound negative 9 raised to the 99th, upper bound 6, mean is 7, standard deviation of 1. And we get 0.1586. Box that in. All right, question number 8. The utility bills for a household in a town follow a normal distribution with a mean of 120 and a standard deviation of 25. What percent of the households will have bills less than 100? So we're looking for the probability that X is less than 100. So that means my graph is going to look something like this. We're going to be centered at 120. That's our mean. But we have 100 down here, and we're going to negative infinity. So there's my lower, here's my upper. So this is going to be a NormCDF. Lower bound, negative infinity. Upper bound, 100. Mean, 120. Standard deviation, 25. Don't forget, lower, upper, mean, standard deviation, or LUMO. So let's run that through the calculator real quickly. Second vars, normal, CDF. Lower bound, negative infinity. Upper bound, 100. Mean, 120. Standard deviation, 25. And we get about 21%. So 0.2118. What percent of that have household bills between 100 and 200? So we want the probability that 110 is less than X is less than 140. I said that wrong. Probability of bills between 110 and 140. So drawing a picture of this, we're still centered at 120. Now 110 is definitely below 120, so it's somewhere down here. And 140 is definitely above, so it's somewhere up here. And we're looking for this area right here, with this being my lower and this is my upper. And the 120 represents our mean. So we're going to have a NormCDF. Lower bound 110, upper bound 140, mean of 120, standard deviation of 25. So that's my LUMO. Standard deviation. That looks like an O. And when we go run this, second vars, normal CDF, lower bound 110, upper bound 140, mean, oops, gotta start over. Second vars, normal CDF, lower bound 110, upper bound 140, mean 120, standard deviation we said was 25. We also have it there. And we get about 44%. So 0.4435. What percent of households have utility bills more than 150? So in this case, we're looking for the probability that our utility bill, our X, is greater than 150. So up here, we established our mean as being 120. So our mean is 120. There's our there, and we want a probability that it's more than 150. So we're shading up. And please remember, we're shading to positive infinity. So with that said, this is the norm CDF. Lower part of my shading is at 150. The upper part of my shading is at positive infinity. We have a mean of 120, and our standard deviation came from the problem above, and at the standard deviation is still 25 because that's what they told us right here. All right. So lower, upper, mean, standard deviation. Second VARS, normal, CDF, 150, 9 raised to the 99th, 120 and 25. And we have 11.5%. So 0.1150. Box it in. We're looking good. All right. Appreciate you watching. Hope to see you on the next one. Thank you.